In this lecture, we are going to study about power in AC circuit. An AC circuit consists of resistive, inductive and capacitive components in them, while a DC network consists of only resistive components. Because of the presence of resistive component in a DC network, power can be given as P is equal to V into I, as voltage and current lie in phase with each other. While in case of an AC network, voltage and current goes out of phase because of capacitive and inductive components. As a result, power in AC circuit are classified into three types. They are active power, reactive power and apparent power. Let us consider the example of a packet of chips that we buy from the shop. A chips packet consists of both chips and air in it. We can eat the chips but not the air. Similar is the case with AC power. The chips that we eat is called as active power. The air that we can't eat is called as reactive power in AC circuit, while the total amount that we pay for both chips and air present in a packet of chips can be called as apparent power. Let us see about equations of these power.
The first type of power in AC circuit is the active power, which is denoted by capital P. It is the power which is actually dissipated in the circuit. It can be given by the equation P is equal to Vrms into Irms cos phi, or it can be given as P is equal to I square Rms into R. Unit for active power is watt. The second type of power is the reactive power. It is denoted by capital Q, where Q is given by Vrms into Irms sin phi. Reactive power is the power which is developed in inductive or capacitive reactance of the circuit. Hence, Q can also be given as Q is equal to I square Rms XL, or Q is equal to I square Rms into XC. The unit for reactive power is var, that is volt ampere reactive. The third type of power is apparent power, which is denoted by capital S. It is the product of RMS value of voltage and current. It can be given as S is equal to Vrms into Irms, or S is equal to I square Rms into Z. Unit for apparent power is VA, that is volt ampere. Let us see the relationship between the powers from the right angled triangle shown here, where S is the hypotenuse, Q is perpendicular and P is the base with an angle phi, where S is apparent power, Q is reactive power and P is active power. It can be given as S is equal to root over P square plus Q square. In complex form, it can be given as S is equal to P plus JQ. If the equations are written based on the units, it can be given as kVA is equal to root over kilowatt square plus kVA square, where kVA is apparent power, kilowatt is active power and kVAR is reactive power.